Peter, thank you very much. Hello, welcome everybody. Happy to have this webinar with you. My focus in the beginning actually will be on technical monitoring, and later on I will hand over to Ola Tyson for building commissioning. As he had said, I'm CEO of Synavision. Synavision is a software company providing quality management software for building performance, and I also do a lot of research at Technical University of Braunschweig on exactly this issue. I'll jump right into my slides. Starting with a development that hit us over the last years, and I've selected a couple of buildings here that are quite typical for what happened here. On the left side, you can actually see this tower that is a typical building at our university here, and actually it was built in 1975, and the level of automation was very, very low. Actually, if you count the BACnet objects here, it's a very low number. Basically, it's district heating going in with 2 supply circuits. That's it. The middle building was just retrofitted. It's an office building at our university, and actually it has been retrofitted, a little more modern, and so today this building has about 1,500 BACnet objects, so it's quite a little more complex. And on the right hand side we have a lab that is quite new, and that already has more than 6,000 BACnet objects. So this is showing how the complexity of buildings is actually exploding while we make use of modern technology and BACS. And of course, if we look ahead in the near future, we will have lots of our devices in the Internet of Things, so we will have even more different objects, software objects in our buildings. So complexity is very likely to further increase. Next slide, similar development. Actually, right here, what you see here is a very small brochure published in 1973, and it explained on 15 pages what building automation was. So BACS had a complexity of 15 pages, more or less. And actually, today you have thousands of pages in all different standards, norms, BACnet guidebooks, etc. So also here, things exploded. Sorry, this is in German. I'll explain it to you. This is basically the scope that an engineer has to handle in terms of standards, norms, guidelines, etc. when designing a heating system. And so you can imagine this is extremely complex, and this also reflects the complexity of technology that we have today. And the bottom line actually in the end is we have very, very good buildings with a lot of potential, but unfortunately complexity has strongly increased, and so often we end up with a building that is simply not doing what it's supposed to do. You stand in front of a switchboard and you simply don't know what is going on. And this is a bad situation. We have to deal with it, and we think that doing so could help us to actually make use of the potential that we have with modern technology in our buildings. Right now we face a situation that basically everybody in buildings is overstretched. Everybody is drowning in complexity, in new guidelines, new technologies, etc. And actually, when you talk with owners, engineers, contractors, or facilities managers, they basically all agree it's getting more and more complex, and it's even accelerating more and more. So our approach here with technical monitoring and building commissioning is to apply quality management to buildings. We think, and we have seen this in all kinds of other industries, if things are getting more complex, you need quality management. Otherwise, you will not be able to handle this kind of complexity. And to explain a little what our approach is here, I will change slightly the subject, and I will change to baking a cake. The performance of a building is something very complex. It's very difficult to explain what the performance of a building is and to evaluate whether it's good or bad or something in between. And this is somewhat similar to the taste of a cake. It's quite difficult to evaluate whether the taste of a cake is good. You can look at it like you can look at it here on the slide, and you will have difficulties to, although you see it, you will have difficulties to tell whether it tastes well or not. Of course, you could do some kind of chemical analysis, or you can invite friends and, well, taste the cake. Unfortunately, afterwards it's gone. Well, bottom line, it's quite difficult to sort of evaluate the taste of the cake as a whole. But there is a very simple methodology to ensure that this is a good cake, and that is by baking the cake along a recipe. If you put 500 grams of flour together with 250 grams of sugar, 250 grams of margarine, put some milk into it, 4 eggs, mix all that, and put it into an oven for 60 minutes at 180 degrees, you can be quite sure that this will be a good tasting cake. Second fortunate aspect here is, while it's very difficult to evaluate the taste of the cake, it's very simple to evaluate the quality of all the amount of all the different ingredients you have here. You can pretty much rely on that flour and sugar that you buy in a supermarket is of good quality, as you can rely on that an industrial product that you build in your building is of good quality. But the amount and the way you put it together actually can be evaluated very, very simple. You can precisely measure 500 grams of flour, 250 grams of sugar. You can count 4 eggs and measure 180 degrees in your oven. So actually, what's the bottom line here? If we sort of drill down the complexity of building performance to individual aspects that can be measured and evaluated, that can be a key to quality management in buildings. And that is exactly what we are proposing. We are proposing a quality control loop that looks at those individual features of buildings. And this quality control loop consists always of 4 elements. Those 4 elements are a set point. You always need a set point, a target value, like 500 grams of flour or 180 degrees Celsius in the oven. This is very important, and it's often neglected in buildings. Often those target values are not precisely described. The second aspect is you need a metering value. This by now is actually quite easy, because today we have so much data from different systems, from valves, from pumps, from boilers, from chillers, etc. They all provide data, and we can make use of that data. So the data will be there. The challenge for a quality control loop or a quality management process is actually to sort of define pairs of target values and metering values that match in a way that the fulfillment of the target value can be evaluated using the metering value. This is not as simple as it sounds. You can, for example, calculate or simulate the energy demand of a building, and you can also measure the energy demand of a building, but comparing both is quite a challenge, and often it's pretty crappy what you receive and what you get out of it. So it's not easy to define those target values and corresponding metering values, but this is the key to quality management. And then there's a 4th element, as I mentioned, and this 4th element is that once you have the result of the evaluation, you need to make an impact. You need to make an impact into the actual building process. That is extremely important. You need to make an impact early enough and precise enough. So it's of no worth when you sort of, well, have a building, it's finished, or a big retrofit measure, and you take 2 years to evaluate, measure, etc., and then you have a result. There will be nobody listening to you, because after 2 years, well, everybody's gone. All the people who did the design, all the people who did the construction are gone. They're working on different projects. So it's simply too late. So you have to have an early impact, and you have to have a precise impact. You have to tell people exactly what the problem is. If you tell them, well, the performance of the building is not good, well, nobody's interested. Huh? But if you tell somebody, okay, this valve is not moving correctly, then, well, you have somebody to address. So this is very important, and this is the key element of technical monitoring that we are proposing. Of course, if you make a lot of those analysis and quality management, you can actually learn for future projects. All this is called technical monitoring. This is quality management for new constructions, retrofits, and even possible to be applied in existing buildings. What this is not is optimizing. If you do performance contracting and you sort of offer to the market that you have a situation before, then you do something, and you have a situation after. You're being paid by the difference somehow. That is optimizing. That's different from quality management. We think that quality management in terms of technical monitoring and commissioning can be of great value because it's a very precisely defined process that we are following. And actually, I would like to introduce you in a little more detail to this process. Actually, last year, we were able to publish a guideline together with the German Ministry of Building Infrastructure. And this guideline is now actually the basic document for a service that actually public authorities are tendering right now on an increasing scale to public buildings because it's working well. And this document basically describes in a very short document, has about 30 to 40 pages. It's available in English. If you go to the website of AMEF in Germany, you will actually be able to download it in English. So you can all read this document, download the documents and the annexes. Basically, this document defines the procedure for quality management. It defines how to derive target values from the design, to give recommendations for the project setup, and how to carry out a test operation sequence to analyze whether the building is actually performing as intended. It has a lot of working documents which are very helpful to implement the service in your projects. So it's not a sort of a theoretical document for researchers. It's a very hands-on document that you can actually use in real life. So what do we have? We have 3 steps here. The first step is in design. Here, basically, you define technical objectives. You define for example, the supply temperature of a boiler, the return temperature of a boiler, the supply temperature of a chiller, the pressure loss in an air handling unit, or the supply temperature in an air handling unit. Whatever you want, this can be precisely defined, and it's precisely named in this AMEF guideline what those technical objectives are that need to be defined. Second is a definition of testing procedures, which basically is a very short period of having the systems that you look at run in an automated mode. So the chiller has simply to work as a chiller in automated mode. That's basically all there is to it. Then we have this trial operation. This is the second step. So the contractor has built the systems, the automation is in place, the BACS is in place, and now you let the system run, for example, for a week or 2. Very crucial point is then the BACS contractor hands over the operation data, which is there. All systems can provide this data. And the technical monitoring service provider is checking whether the system was running the way it was specified in the first step. And of course, once you have done this, you can report on it, and you can continuously report on it. Once you have defined those technical objectives, you can of course keep monitoring this, or you can have repeated tests like quarterly or annual testing as you like. Just a quick walkthrough through the different steps. Basically, in the first step, you specify the different parameters. You specify, this is very important for tender documents, you specify how data from BACS has to be handed over. This is a very crucial step. And basically, you hand over data, the testing specification, the tender document for trial operation, and a tender document for data export. And actually, all those documents are presented in the AMEF guideline in English language, so you can download them and use them in your project. The second step actually is monitoring, and here you can see just some screenshots from the software that we are producing. Synavision has produced a software based on this process. You can basically do very precise testing of everything the contractor wants to hand over. So once the contractor says, I'm done, I'm ready for testing, Well, he gives you an example of his export data. You check whether it looks fine, whether you can test it, and then the contractor runs the system as specified, hands-off operation, automatic mode, and afterwards he hands over the data to you, and you as a technical monitor, for example, if you're providing this service, you can actually check the data and write a report. And of course, you can do this continuously with the right software. You can produce automated reports or dashboards or whatever. Some very important aspects here for technical monitoring. This is the whole procedure. Very, very straightforward, very short actually to implement, very easy to implement in projects. But a couple of aspects are important. First, the technical monitoring service provider is an independent third party. He is testing whether the building owner receives what he is paying for. Therefore, he needs to be independent. He's never the engineer nor the contractor. He's an independent third party. Second, we precisely define what target values have to be specified for different technical systems, for a boiler, for a chiller, for a heating circuit, for an air handling unit, etc. This is the minimum standard that has to be specified. So as the monitoring service provider goes to the engineer and says, okay, you have a chiller plant here, please tell me what are the objectives for this very component that you're planning here. This is specified very clearly. And the second aspect that is specified very clearly is the way the data from BACS has to be handed over. And you can see here, it's very unsexy, very simple. It's a CSV file that we recommend with date and time right here, a small header with the name of the data point and all the metering values underneath. Very simple, but very robust, and well, a solution that works in real life. Not very sophisticated, I admit, but projects have shown this is what works. You can do a lot of other things, of course, in addition, but you should always rely on this very simple solution. Okay, well, basically, this is the general idea of the process. There's one aspect that you can define in addition when you do this kind of service. You can, of course, define some typical actions that should be done within the trial operation. I said it's automatic mode. Yes, it is automated mode. But of course, you can ask for certain changes. You can, for example, provide a schedule that says, okay, within our 2 weeks of trial operation, I want some characteristics to be changed. I want to have some schedules to be changed. Maybe you can just unplug a sensor and see whether the system is reacting as it's supposed to react. Maybe you can overwrite the CO2 concentration in a seminar room just to see whether the air handling units and the variable dampers are reacting. So this is what you can, of course, specify depending individually on the system that you're actually testing. What is important in the end is that once you have the data and once you have your specification and you have the data and you compare those, it's important that you have a precise result. The result should not be a lot of lines, line plots where you have to, discuss whether this is okay or not okay. Be very specific. It's green or red. It's fulfilled or not fulfilled. That is important for this process, and it's possible to make this evaluation as precise as I'm describing it here. It's a green light or it's a red light. Getting data out of buildings today is quite simple. Even in small buildings, you can just, of course, design and install individual metering devices, but I think for the future this will not be necessary and way too costly. I think it will be much easier to use manufacturer gateways, example for CHP or for chillers or boilers. Many manufacturers already provide gateways that will give you a lot of data from the individual systems. And of course you can use BACS, building management systems, building automation and control system, that also can provide all these data. All those systems are capable of it, and the only thing I think that is really important is that all this is in the in the tender documents so that it's part of the contractor's service. Once you have that in place, you can see a lot of typical problems of buildings right before you actually hand over the building. Before you sign the final acceptance documents, you can actually see, for example, here, examples from some of our projects, a very unplausible ambient air temperature. There was a sensor on the roof and it was not protected from sunlight. And so while you see the black temperature here was the real temperature, actually this is what the system, the BACS system measured. And of course this messed up the whole controls system. Here you have an example of heat pump supply temperature in residential buildings with multi-story buildings. The heat pumps of those 4 heat pumps supplied identical buildings. They should all look alike and have some kind of characteristic where the supply temperature goes up in winter, like here. In winter it should be higher, like 35 to 40 degrees, and in summer it should be very low. Well, unfortunately, in 2 buildings, the heat pumps supplied, well, basically a mess of temperature, with temperatures going up to 50 degrees and more, and of course the coefficient of performance is very poor in those systems. This is an example of a detail that we found where we have this often in big chiller plants or heating plants where you have triple or double pumps, and especially in triple pumps you often have pumps that work alternately. So the pump is working here and then it stops, and then it's working and then it stops, while the other pump stops and is working, stops and is working. And actually in this sequence the third pump should always also be a part, but in many buildings we find that it isn't. There are some reasons to it. Usually the first pump was set in operation during the commissioning phase and then manually, and in the end somebody forgot to integrate it into the sequence of operations, and so it's continuously running, using a lot of energy, electrical energy, and of course potentially messing up the hydronic system as well. And here you can see a very typical problem that we also found in many air handling units. Well, in Germany and northern parts of Europe, of course we have air handling units with heat recovery systems mostly for the winter time, and actually the system should, as you can see right here, with 15 degree ambient air temperature, it should produce, or with 10 degrees ambient air temperature, it should produce something like this, like 15 degrees behind the heat recovery system. So it should lift the temperature from like 10 degrees to 15 or 16 degrees. And here you can see 2 other systems, and there is absolutely nothing happening. Actually, in those 2 systems, both are in a medical lab operating 24/7, and those 2 systems used an excessive amount of energy worth about 120,000 euros in the first 6 years of building operations. So just a couple of examples of very simple aspects and faults you can identify with quality management. Very simple, no additional metering technology actually necessary. All the data was available. All that was necessary was to define the specs in the beginning, and to define that you want to have trial operation and that you want to have the data. And well, if you look at the numbers that we get here, just a couple of examples from indoor pools, office buildings, hospitals, etc. The payback times in months are pretty encouraging. It's usually below a year, and the amount of money that you can save over the lifetime is tremendous. So from our point of view, this is a very, very attractive concept. Many attractive features. The service can be robustly scaled up, which is extremely important because they have a large number of buildings. So I think as a core issue of quality management, technical monitoring is really a very, very good opportunity to increase the performance of our buildings and to reduce the performance gap between design and operation. This is, and as we are writing right now, a guidebook for REWA. This is one part of quality management, and here you can see a kind of table showing the different phases going through a building, starting with the owner's project requirements, etc., going through commissioning, etc. This is what Ola will be talking about. And actually, technical monitoring is sort of the core of this process. It should always be there, but it's not all of it. There are a lot of more aspects to buildings that are not covered by technical monitoring, and they can be covered by commissioning with a lot more scope, a lot more detail, and on this, Ole Theisen will give you an overview. Ole, hand over to you.
Thank you, Stefan. Now, let's have a look at the building commissioning process. This is Stefan's final slide. And I have here an example of the building automation and control system. I don't know if Stefan he is able to use this for his for his technical monitoring, but they are out there. These usually they will be modernized and we get something better than that. We are going today to talk about something that could give us a little more knowledge about the building commissioning process in itself. What is the building commissioning process? And to do that, we actually show us what to have a look at. And then we have this case could be used both for introducing you to the quality gap, what can go wrong in the building, and also to how to actually attack an existing building with the building commissioning process and the tools of the building commissioning process. And then there are some important interactions with the traditional quality assurance that the owner has always bought, that has always been in the building process. And then we talk a little about and get a little knowledge about the stakeholders' roles in the building commissioning process. So at the end of today, why use building commissioning process and how do we do it? Contractor quality assurance, prerequisites for tests, and ongoing commissioning activities and monitoring-based commissioning. Here's a story from the real world. And you can actually read yourself. There's no reason for me to mention everything that's on the screen. But there was a domicile that actually everybody was very satisfied when they had their handover of the building, and they even gave a prize to the building because this is outstanding, this fine quality. But the daily life came short after, and something else happened. What happened was actually that they had severe claims about the indoor climate from the inhabitants in the building. This was a turnkey contractor, and he actually was asked to compensate or to solve the problems with the indoor climate. And then he found something probably he could tell his subcontractors to do, and then he said, no, it's all right. But the complaints continued, and then the client advisor, he came there and he analyzed something. He also found a few things, and then he got some kind of feedback from out there. Now they have corrected these things, and now he said, now it's all right. But it wasn't, because after that, a professional commissioning team came there and tried to analyze what was happening in that building. And as you read here, that was actually, this was very, very bad things and very costly things to deal with. Everything, actually we have a catalog of almost everything that can be wrong in the building. So one of the strange things we found was this architecture that we actually got a prize was one of the main reasons for overheating the area where people worked. And when these areas were overheated, there was a huge inlet of cold air which caused draft. So everything was actually going very, very wrong. If you see these cassettes with glass were heated up by the sun, and then you had something almost like a very hot surface indoors to make the indoor climate very hot. So conclusion is indoors climate requirements are not met, and we have 50% dissatisfied employees. I think it was more than 50%, but 50% was openly dissatisfied. And energy consumption was also way more than the budget. Now we have the existing building commissioning process that actually initiated that we found these problems by making the relevant analysis, and then we have mapped the requirement, tested the building, and the designers were hired to find a solution. The designers are not the same as the commissioning team, because the commissioning people have to be independent of the design. And then the solution is implemented, and you can actually run a normal commissioning process on that solution that's implemented. We come back to what is that. Here is a little photo of what happened there. The photo shows, if you have a look, you can see 4 imaginary people coming here and or sitting around the desk. I'll have to see if I can find this for you. There are 4 people. Each of these 4 containers contain a 100-watt heating element. You have a heating element on the table that actually has the same size as 4 computers. So you have actually a heat load that's simulating that you have a normal working environment. And here you have the window that's covered with a piece of chipboard. This is actually floor heating cords that's spread out here to assure that the heat load coming into the room while we make the test is the same as we have measured coming in real life from the window. And then you have measuring devices measuring radiance and temperature and air velocity and temperatures in general. A lot of devices here. This air velocity device here is actually because above this there are chill beams that could give or gave a lot of draft when they operated. You don't always have to use such accurate equipment. Here's another situation where you see one of my colleagues, he's actually into making a measurement of a rooftop unit, and he's chosen a sufficiently calibrated instrument for that task. If you have a look there, you can see this rooftop unit is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 feet wide. If you look at that, and then you can go on here and see that the distance to the next rooftop unit is 1, 2, 3, 4, 5, 6, 7.5 feet. And then you can ask the question, is there any room for taking out the elements of that unit for service, or is that a correct placement? Of course, that's not smart to find out of that when the rooftop units are already in place. But sometimes you don't have a chance to do it before. It should be found in the design. And if we try to question the accuracy of the measurement device, I think there's no question that this measurement device is accurate enough for the task. Now we go back to see what are we actually trying to do with all this. We're trying to get a proper indoor environment. Here's a nice little man here. And have a look. If I can show you the green arrow, he's very happy. He's having sunlight from the window, and he's having temperature and air quality that's actually sufficient for his needs. To keep up that indoor climate, there's a lot of gear to make him keep happy, including controls. To keep that gear happy, there's a lot of other gears. To make that function, you need even more. The point here is, if only one of all these things fails, the man will not stay happy. So why should we do something special to cover all these items that actually need to interact perfectly if you want the indoor climate to be good? You have here symbolized a building, you have symbolized with a cake, and the cake consists of a lot of suppliers' contribution. The commissioning process is actually what fills out the gaps between the slices of cake. So what can go wrong? Because what you saw at the other building, you couldn't say it was only the contractor's fault or it was only the design fault, because I could ask the owner, what have you actually ordered? Have they been very clear in what they have ordered? So, and often we see that owners' requirements, they are too fluffy. They don't have clear requirements for what they want. We also see that the building is with intentions. I don't know why, but that's very often. If you happen to get good requirements, or clear requirements, requirements that can also be used as a basis for Stefan's technical monitoring, then the design might not be following the requirements. And if you happen to get a design that follows the requirements, then it can also go wrong in construction. And if it goes right in construction, you have the last chance to make it go wrong in the operations phase. So we actually have to deal with all. We should be sure that your requirements in the beginning, they should be clear, measurable, and you should be able to find them and measure them in the operations phase. Then you have actually passed the commissioning test. It's described by the International Energy Agency in a publication called Annex 47. It's mentioned here. And as you can see, the commissioning process, what they call initial commissioning, begins in the pre-design phase and actually continues all into the occupancy phase. And then they have after that something they call ongoing commissioning, which we should talk about later. We also have an initial commissioning here that actually then stops, and then something happens to the building and it's not really maintained, and then they do a recommissioning later. Or we have, if they have had no initial commissioning, then we can start a retro commissioning later on. So here is the commissioning process on a shoestring. In the pre-design phase, we should facilitate that we get measurable requirements from the owner. We should review design requirements. We should review the design to assure that the requirements are followed. We should test, train, and document. We should set up technical monitoring if we can do that. And we should continue testing and monitoring in the operations phase to assure that our good work still is continuing. If we take the commissioning process for existing buildings, it's almost the same, because you start with planning, and planning phase you get the owner's project requirements. That's the same as the other one. Then you have an investigation phase. That was what we saw in the case, where we actually examine what is there and we test. Then we review the design, and when we get a design, because that is what is renovated, is have to be designed, and we actually run here an ordinary commissioning process from there on and forward. These are the mandatory documents of a commissioning process. And you can see we have one of the most important ones is the owner's project requirements. That's the basis of all of it. We can't measure if we don't have the owner's project requirements as accept criteria. Here's a typical organization. I know that the organization Stefan he came up with was very more simple, but it's also a simpler process. But this is a typical commissioning process organization. So commissioning is quality management process. And you can read there's a lot of it. What's much more interesting is what is commissioning not, what people think commissioning is. It's not startup of technical installations, because that has always been there. And the owners have always bought somebody else to do that. We shouldn't go in and take over that. And it's definitely not just a quick fix or testing in the end. And it's not a police task. With that we mean that if you think that actually you could go in there and just say yes or no, of course you should say yes, and you should say no to something. But the best thing you can do is to set up a cooperation and actually add value to all parties. Then you get a good process. Commissioning actually enforces all the necessary cross-disciplinary checks before occupancy. And before we can do that, we have to make sure that everybody has done every contributor to a cross-disciplinary indoor test as the one we saw before. Our efforts are not worth, our result is not worth the effort if everybody who has contributed with the system, they are not finished with their work. Here is an example of that. It's probably not very readable on the screen. When you get the PDF after, you can actually have a better look at it. You see, these are the interactions between different quality assurance activities and what should be prerequisites for other activities. If you want a better copy of it, you are all welcome to contact me later on, and I will send you a copy in a separate PDF. But these green boxes actually illustrates that it's mechanically complete things are built and finished, and the quality assurance for each system is done. And then you have, here you have the activities you have to do to get further on. For example, if you go here, you want to start up pumps in the heating system. But before you can start up pumps, you have to flush the system and pressure test it. Then you can start up the pumps. No, you can't, because you don't have any electricity. You need that from a BMS switchboard. And if you don't have the BMS switchboard up and running, you need some other switchboards to run, and a transformator station or whatever. All this must be fixed before you can get your pump up and running, and you can come to your balancing task here. And that means that you need to think out of your silos for each delivery, because you can't actually get very far in your verification process or your balancing process or whatever before you are highly dependent on all the others. So try to study this thing. When you come here and you have done all these heating startups activities, you can balance your heating system. You can balance your ventilation system. And when you have balanced all the other systems, you can balance your BMS. Then you can make a site acceptance test of each of the systems, and you can assure quality, and you can document, and you can actually train the personnel, and then, and first then, you can make cross-disciplinary checks and tests. The coming commissioning activities in the future could consist of deferred tests, seasonal tests, some other activities, including the ongoing and monitoring-based commissioning activities. There should be a plan for these ongoing and monitoring-based commissioning activities, and that should include these things: the requirements for monitoring points. And that's very much requirements for the BMS system, because you set up monitoring in BMS system. And if you don't get the monitoring points, neither the commissioning process nor Stefan's technical monitoring process have a chance. And these requirements should be set up by the owner in the beginning in the owner's project requirements. Then we should describe the procedure and what we need to maintain the things. And we should ask for operator training for monitoring-based commissioning services. And I think that's the weak point. I've seen a lot of setups with monitoring-based commissioning that actually have failed because they have not rooted the necessary human resources in the direction of analyzing the data. Why should we start so early? And the answer is very easy. To have impact on the project is very easy in the beginning. And if we get good ideas later, they become more and more expensive. And remember, you need good skills. You need good people to analyze your data and evaluate your results. Actually, this is a screen grab I took on somewhere we were out. I admit I don't have the skills to analyze that one. And there are a lot of material out there that actually describes the commissioning process. You can have a look here. And there will here in May 2019 be 2 new publications available from RIVA. One of them is the Quantum Handbook about the commissioning process and the stakeholders' role in the commissioning process. And the other one will be a very technical one for commissioning providers, how to actually do the individual tasks in the process and document it. So we are now at the end. and we invite the participants to ask questions.